Hey there, everybody. Welcome to week 3. So this week we actually get to dive in a little bit with statistics. And so here we go. The next 3 weeks or so, we're going to talk about quantitative statistics. But again, at a pretty basic level. And as I mentioned, in the past, a couple of times at a level where you can understand it as a usability level, so that when you read research or when you design or develop programming on your end, that you know kind of what you're doing as far as what sort of tools are appropriate to use. Certainly when you're reading research, so that the language is familiar, because sometimes that's the issue, right? So a lot of people will have a tendency to read a research article and skip right over the methods section because there's language in there they don't necessarily understand. And that's totally fair. We're not trying to become statisticians from a course like this, certainly, but at least when we read articles that we'll have an idea about the language they're using, the tools, and then hopefully why they're using those particular tools in that case. So anyway, the readings for this week, for week 3, are chapters 7 and 8 in our book. So it starts off with some very basic language to kind of get us up to speed on a couple of important fundamental principles relative to quantitative statistics. And so, chapter 7 just really starts off talking about statistics and how it's important to do, from someone who's doing research, but also someone who is consuming research. This is mostly us, me included, in that. And as I think I've mentioned before, on a lot of research projects that I do and have done in the past, we have statisticians that we will work with to make sure that we're doing what is appropriate on our end, and what tools to pick and so forth. And so I'll probably continue to talk about that as we move through the course, because I think it's a good thing to realize that, especially a course like this is not meant to help you develop into an independent researcher where you could do all of it on your own. And certainly there's computer programs that help. But if we're not using them in the right way, if we're not really sure what the programs are doing, if we don't set it up correctly, then that's not super helpful either. So I think this course would be good from a quantitative data side, from that end, just to give us the basic knowledge I think that we need. So that's where really chapter 7 opens up, and to say that. And I kind of like one of the analogies that says, well, we all operate a car, but we don't know all the intricacies of how the car works. And I think that's the same for statistics. I think we can still use them without having to become, a high-level statistician, mathematician, to be able to do the work that we want to do. So it starts off with some very basic knowledge about nominal data, ordinal data, interval data, looking at what that language means, even though that, sometimes when you get into reading a research article, that typically use that language, but it's good to, to know what kind of data we're looking at. And certainly within the book, those words are gonna be used. So having a baseline understanding. Nominal is just talking about the differences. Ordinal is the difference and the direction. And then interval shows the difference, the direction, and the amount of difference of the data. They do move then into parametric statistics, and then give a mention about non-parametric statistics, and really what is talked about through chapter 7, and then mostly in chapter 8, are parametric statistics, because it talks about the distribution of the data being on a normal curve. And we're going to talk about that in a minute when we talk about chapter 8. And so when we have a set of data and it is within a normal curve of distribution, then we can use parametric data. If it is where the data is skewed heavily to one side and it's not normally distributed, again, we'll talk about that in a second, then we have to use non-parametric analysis for that. Okay, so that's the difference there, and hopefully that makes sense. here in week 3 because there's a lot of time spent on what normal distribution looks like, or a normal curve or a bell-shaped curve. We'll talk about that in a second. Then there's a little bit of conversation in chapter 7 talking about descriptive statistics and inferential statistics. So, and this is good to keep in mind here when we're looking at something like, say, the cardiovascular and diabetes risk reduction program and the data we collected there, that the data that we are talking about is just descriptive data, excuse me, for the people that are in that study or in that program itself. And that may be the same for you as well. So the program that you develop as we get to the end of this course and you develop this group-based program, the data that you would be collecting is probably going to be descriptive data within just your people who are in that program. And how we did it in the risk reduction program is we measure pre and post, and then sometimes measure throughout at different intervals throughout the time when the person is in the program. But looking at, say, the pilot study we did, it was looking at data before they started versus data when they finished, and that was descriptive for just the people in the program. We didn't then extrapolate that and infer that that was the same results we would get for the entire population, say, of Creighton University or Omaha, Nebraska, or the United States. We didn't go there because we couldn't go there. That wasn't a representative sampling for us. We would be making some errors in our statistical analysis if we went in that direction. So we were just looking within the population, and that was descriptive statistics. So then inferential statistics is something where you grab a random sampling of people and you then say that it is has enough predictability because the random sampling was done appropriately, that you could then infer some things about the larger population. So as this is, kind of easy to imagine, if you took a bunch of graduate students, then you sampled them from many graduate programs across the country about their attitudes or, maybe say stress level. Maybe you could make some inferences if your sampling size was large enough and represented the entire, population. But if you just took, if we just surveyed people within the Integrative Health and Wellness program about what their stress level was, at Creighton University in our program, that we couldn't make an inference about everybody in the United States about their stress level because it's not an adequate random sampling of all graduate students. So those are some of the things I think that were good mentioned here, and really the little bit of conversation about how to get a sampling, and this will again come later as we make our way through the book. There are ways to do this, and certainly you would use computer software to, if you had a group of, say, Creighton University employees that you wanted to ask, again, maybe their stress level, that you would use some type of software and some method to be able to say that it was a representative sample of the entire university, as opposed to just biasly picking people you have access to, like just the people that I work with, and then trying to infer that the entire university feels the same as the people that you work with. There's some inherent bias associated with that, and there's some sampling error, as it's typically referred to in statistics. Okay, so that's chapter 7. But then we move along to chapter 8, and I think we get into more of little bit of the nitty gritty, talking about some of the more, statistical language, and very useful for us when we're looking, I think, at, reading research studies and some of these very basic principles of just the language and what it means. So it talks about, in the beginning, talking about central tendency, and I think everyone's probably familiar with mean, median, and mode. But it's often used, that language is so heavily used in research projects, particularly mean and median. But so mean would just be out of a distribution of scores, say, or a data set, that it's the average. So that's simply mean. Median is the middle score. So the one that's right at the 50th percentile, or the 50th percentile, I guess is the best way to say it, of a distribution of scores. If it's an odd number, then it's that middle one. If it's an even number of scores or data, then you take the middle two and you average them together. So that's the median. And then the mode would be the one that's most frequently, that you see the score or the piece of data that's most frequently reported. So it could be, along a data set that you've got, 100 scores of something, maybe a test that you're looking at, and you had, out of that, 20 people got the same percent score, like say an 88%. That would be the mode, would be that. So then it moves on into talking about variability, because mean, median, and mode are great. And so let's talk about mean. So we have a mean score of, say, a test score of 88. How does that, is that a good score? Is it not a good score? It doesn't really tell us anything except that it's a score of 88. And so what variability shows within the data set is how much dispersion there is. So what the range is of scores. And so it's something that we can make sense with. How widely spread are the scores, and whether the scores are similar to one another or not. And so that's the purpose of variability, is it tells us more than just the score. It tells us something about the rest of the distribution. So that score relative to the rest of the distribution of scores. And I think I like the example that they give in the book, talking about if you're planning a trip to the mountains and you're packing your bag on what kind of clothes to bring. And, in summertime, and as in the mountains, that, in the summertime, it might be nice and warm, but at night, in the daytime, but at nighttime, it gets a little chilly. So you wouldn't want to just look at the average daily temperature. You would want to look at the range of temperatures. What's the nighttime temperature and the daytime temperature? And that's going to give you more information, so you know what kind of clothes to pack in your bag. So I like that example. I think that helps us with variability. So when range is reported on research studies, technically it is just subtracting the scores, the low score from the high score. So in the distribution of data, you just subtract the low and the high and you get one number. But most of the time, what researchers will do when they report range is they'll say both the low score and the high score. Okay, so you have some a little better sense of what that is. So thinking about the nighttime lows for temperature versus the daytime highs for temperatures, and that gives you a more information and helps you understand a bit better, and in this case a bit better on what kind of clothes to pack. So then it moves into standard deviation. This is an important concept that perhaps is something that maybe was maybe a little bit confusing prior to reading the chapter. Hopefully the chapter clarifies some things relative to standard deviation, but it provides information about the score's distance from the mean. Okay, so if you have a data set and you get a score, what is that? How does that fit into the whole data set? Where does it lie? Is it above or below the mean, and how far away from the mean is it? And that's standard deviation. So it gives you, again, more information. It's the most frequently used measure for variability. The larger the standard deviation, the more variability of the scores. So they're spread out more. Okay, the smaller the standard deviation, the closer the scores are together, and perhaps more similar the scores are. Another, just as a side note that they put in here too, important to understand that the coefficient of variation is an important concept, because it allows you to look at scores that have different distributions. So then maybe like scores for men are different than scores for women. And so it coefficient of variation allows for you to look at both in an apples to apples way, as opposed to trying to compare apples and oranges together. So that's what statistics is really helpful for, in that we can use them, to be able to look at things that are perhaps different, but look at them in a more comparable way. So a few pages are dedicated to the normal curve, and getting back to this conversation we talked about a couple minutes ago. The normal curve is really important to understand this whole concept of distribution of scores, of standard deviation. So having a handle on this piece of it, and what a normal curve looks like and how standard deviations fit into it, is really important, because most of the research we read is going to report mean, it's going to report standard deviation and range. And so having a good handle, okay, I understand what mean means, I understand what range means now. So then what does standard deviation mean? Well, you have to understand a normal curve first in order to understand what standard deviation is. And so they spend a great deal of time on it. And I would suggest there's some great examples that they use. And they use, I think there's 8 examples between pages 93 and 96 in the book. And I would really emphasize, I think, those pages for you to understand the samples, the examples that they're showing there, and what the distribution means. So a normal curve, or also called a bell-shaped curve, is going to give a normal distribution of scores or data across the whole data set. And the normal curve allows us to visualize the data. It allows us to, interpret what that distribution looks like, because it's predictable, on that normal curve. And then it also, I think, as they mention, most importantly, allows us to make some predictions. And that's a good thing. So also called a bell-shaped curve, the normal curve. Here's the piece of it to understand a couple really important parts: that the mean, median, and mode are all 0, and they all line up right in the middle. Okay, so that's your 0 point, right in the middle. Mean, median, and mode are all 0. Anything that's on the right side is positive. Anything on the left side is negative. Don't interpret this as being over here being good and being over here being bad, because that is not, you have to put those labels out of your mind when you're looking at statistics, because sometimes you want them to be on this side, or you hope that they're on this side, and sometimes you hope that they're on this side, depending on what you're looking at. So positives on the right side, negative on the left side. Okay, so then what we're going to do is look at, we have this center line, and we're going to look at how far away our particular numbers are from that center line. So 1 standard deviation away, 2 standard deviations away, 3 standard deviations away. Okay, so most of the data that we collect is going to be within the 3 standard deviations away from that center line. Okay, from the mean. And that's the language I think that's best to use here, is from the mean. So 99% of the data in the data set will fall on a normal curve, 99% within 3 standard deviations on one side or the other. Okay, so it goes out 1 standard deviation, 2, and 3. It's important to note that the shape of the curve never touches baseline. And that you could be out 20, 30 standard deviations to the right or left, but it's a very small percentage of the distribution that is going to be way out there. 99% are going to be within 3 standard deviations. So it's important to, I think in your own mind, to just remember these numbers, that 68% of your distribution will be within 1 standard deviation, 95% will be within 2, and 99% of the people or data that you collect will be within 3 standard deviations away. Okay. If you can get those concepts, then you're going a long way to understanding what standard deviation means. They do then branch off, and this is really a great thing to understand too, in that you calculate a standard deviation, but most statistics, so most research studies will calculate where you're comparing and looking at a distribution. They'll calculate a z-score, and a z-score just gives that exact number distribution in standard deviation units. So it could be whether you're measuring things in body weight or millimeters of mercury or kilograms or whatever it is, that it converts those units over to standard deviation units, and you're able to then look at apples to apples and say that it was 1.67 standard deviations away from the mean, or a negative 1.67 standard deviations away from the mean. So you can picture in your mind that bell-shaped curve. It was on the right side because it's positive, and it was greater than 1 standard deviation away, less than 2, 1.67. It allows you then to compare some, how that score relates to the mean. Okay, so hopefully that makes sense. That's the z-score, and you see that a lot in research. In the research studies. And then the last thing that they touch on right at the end is what happens when you have all of the data that's sitting, most of it is sitting on one side of the mean. So it's not a normal bell-shaped curve, but it looks like it's got a big, chunk on one side, and then the tail goes off to the other side. And that's skewed data. We see it all the time. And a great example that they use in here is like a GPA of a grad student. GPA of grad students are typically higher because the people who are more academically inclined and perhaps better students in an academic kind of way get higher grades. And so they go to grad school and they get higher grades in grad school too. And there are less people that get lower grades. And so there's skewed data. It's not a normal bell-shaped curve for graduate students. It's skewed in a direction that favors higher grades. If you're looking at doing an analysis there, you can't use parametric data or parametric statistics. You have to use non-parametric statistics, okay? So only on the normal bell-shaped curve can you use parametric. You got to move into non-parametric if the data is skewed. So if you're comparing grad students to something, you probably should use non-parametric data or analysis. Okay, so that's as far as we get in chapter 8, and that's a good place to start. So I think we're off and running in a good way for this, and so I hope hope the book makes sense for you, and are continue to work through it. If something doesn't make sense, reread it. They give a lot of examples, and look at those examples, or try to think about those examples in a way that makes sense for you. And that goes the same for the rest of the chapters too. They continue with this same pattern. All right, well, that's it for this week 3. So we'll be back, make another video for week 4, and we'll keep on our journey on the quantitative statistics part of this class. Talk to you soon.